Welcome back to the channel. In today's video, I'm going to talk to you about how we can use the scipy.constants module to solve some typical chemistry or physical chemistry questions. And this is one of those cases where growing up, we're always like, you don't have to remember those constants. And I want to demonstrate how with Python, we have access to Avogadro's number, Planck's constant, the speed of light, and many other physical and mathematical constants, which will help us solve typical chemistry and physical chemistry questions. If you look at this page here, we have access using the scipy.constants module, and you can see we have many of the constants like pi, the golden ratio for mathematical constants, and then many physical constants like the speed of light, where we can either use c or speed of light with underscores, and many others such as Planck or h. And you can see through this list, we can solve all sorts of problems by using the constants that are readily available with the scipy.constants module. So let's solve a sort of standard question. Here we have how many joules of energy are contained in a photon with a wavelength of 455 nanometers, and how many kilojoules per mole of energy is this? And so we can solve this using a series of well-known equations. First, we will convert the wavelength from nanometers to meters, and then we can convert from wavelength to frequency by using the speed of light. So let's set our frequency nu equal to the speed of light, which is going to be constant or con as we import scipy.constants as con dot c, and we'll divide then our wavelength variable. So when we do this, we have our nu, and we can see that we have this value here. Now, the next step is to multiply nu times Planck's constant in order to compute the energy in joules. And so to do that, simply, we'll just set E, and I'm going to set that underscore joules so we know our units, and con dot Planck times nu. And so if we look at that output, we have 4.36 times 10 to the 19. That answers this question here where we have joules of energy. But the second question is how many kilojoules per mole of energy is this? And so lastly, we will solve this with a couple of Python steps. We will multiply energy of joule times Avogadro's number, con.avogadro. And then let's divide by 1,000 to convert joules to kilojoules. And so we have 2.262. And then lastly, let's pass in round. Let's just round this to a single decimal place. And there you have it, 262 kilojoules per mole of energy with a photon of 455 nanometers. In any case, I hope you enjoyed the video, and I'll see you in the next one. Peace.